Okay, so hello guys. So in the last video that I posted, we went over how to multiply polynomials, add polynomials, subtract polynomials, and now we're on to factoring polynomials. So this is an example that is from the book, and again, it's OpenStack's college algebra, so I can post a link in the description down below. So basically it says factor the polynomial using GCF. Now GCF stands for greatest common factor, and we have 6x cubed y cubed plus 45x squared y squared plus 21xy. Now the first thing that you need to do, so basically what we're trying to make it so that we're going backwards now. So when we would multiply polynomials together and we would come up with something like this, now we're going backwards. So factoring is literally the opposite version of foiling. Okay, so the first thing that we have to do here, and obviously we can just looking at these three numbers, right? So we have a 6, a 45, and a 21. And what we can do is we can divide all of these by 3. So if you do that, you get, so 6 divided by 3 is 2, so you're going to put a 3 outside of the parentheses, and you're going to put 2x cubed y cubed, and then plus, and then 45 divided by 3, that is, I think it's 15, x squared, y squared, and then plus, and then you're going to do 21 divided by 3, that's 7, and then it'll be xy. Now, that's the first thing that you would do. So then you would have something like this where, let's just color code, 2x cubed y cubed plus 15x squared y squared plus 7xy, right? So then what you're going to do is, let me just kind of, okay, so now you have, obviously we have an x and a y term, right? So we can take that out. So we have xy, x cubed, y cubed, and x squared, y squared, right? We have these three. So we have x cubed, y cubed, x squared, y squared, and xy. What can I divide all of these by? Like, what's the greatest common factor of these? So what can I divide all of these by so that they divide evenly out? Obviously, they all have an x and a y in common, so I can divide an x and a y out. So I can factor that out. So I can get 3xy, and I'm going to do times 2 and xy, so x cubed, y cubed divided by xy. That's x to the 3 minus 1, y to the 3 minus 1, which is x squared, y squared. So I have x squared, y squared, and then I have plus, and then I'm going to do 15, and then obviously I'm going to do x squared, y squared over xy, which is x squared over x times y squared over y, which is xy, right? So as long as you know you're basically using laws of exponents. When you have x to the n, y to the m over x, let's say to the b, and y to the c, it'll give you x to the n minus b, y to the m minus c. So that's literally what I'm using here. With factoring, it can be very difficult to explain. The way you can check it is you can literally FOIL it back out, or distribute the 3xy to make sure you did it correctly and to make sure that you got the exact same thing that's up here. So we can say, and then we have plus, and then obviously xy over xy is 1, so it's just going to be times 7, because really we have a 7 here, and then xy times 1 is 7, right? So then our answer ends up being something like this. Okay, so that's the idea of doing factoring a polynomial using greatest common factor. Now this was a little bit of a harder problem. I might go over an easier problem in the next example, just to show you guys what I mean by factoring. By factoring polynomial expressions or any type of polynomial. So with that being said, guys, I really hope that helps. Thank you so much for watching, and please like, comment, and or subscribe, and I will see you guys in the next video. Bye, guys.